Mechanisms in motion are short revision videos which show you the effect of arrows in organic chemistry mechanisms. As the format is a quiz, you will be presented with multiple options for how the mechanisms will occur. Based on your choice, move ahead to the timestamp and you will see how your choice affects the reaction. If you are correct, you will move on to the next step in the mechanism. If you choose the incorrect or less likely answer, the reason for this will be explained and then you'll be given the correct answer. At the end of the video, you will see the full drawn-out mechanism showing the curly arrows moving the bonds. Nucleophilic reactions can occur by a variety of different mechanisms depending on the reactant, the solvent, the nucleophile, and other reaction conditions like the temperature. For the following reactions, decide whether each is SN1, SN2, E1, or E2. The first reaction involves an alkyl bromide, sodium ethoxide, and ethanol. Choose whether this reaction is SN1, E1, SN2, or E2. The SN1 mechanism is a two-step process which involves the halide leaving forming a cation. In this case, you would be forming a primary carbocation, which is unstable. Therefore, this reaction would not occur. This same reasoning can be applied to the E1 mechanism, where the formation of the primary carbocation makes this reaction unlikely to occur. The correct answer is SN2 or E2. Both of these reactions will be occurring, but one will occur at a quicker rate than the other. The conditions for the reaction are a primary alkyl halide, a strong basic nucleophile, and a protic solvent. This is the SN2 mechanism. This is the E2 mechanism. As the base used is non-bulky, the SN2 reaction will occur at a quicker rate. This reaction has almost the same conditions as the previous one, except the base and the solvent have been changed. You still have the alkyl bromide, however, now you have sodium terbutoxide and butanol. The SN1 and E1 mechanisms are not going to occur in this reaction for the same reason. The formation of the primary carbocation is unstable. The conditions for the reaction are very similar to the previous reaction with a primary alkyl halide, a bulky base, and a protic solvent. This reaction can occur by SN2 or E2. Both reactions will occur at the same time, however, one will occur at a quicker rate. This is the SN2 mechanism. This is the E2 mechanism. As a bulky base is used, the E2 mechanism will occur at a quicker rate for this reaction, making the E2 product the major product. The next reaction consists of a tertiary alkyl halide and methanol, which is acting as both the nucleophile and the solvent. Based on the steric bulk around the carbon-bromide bond, a nucleophile would be unable to attack the molecule. Therefore, SN2 can be ruled out. E2 is also not going to occur in this situation. While E2 can occur with tertiary alkyl halides, there would need to be a basic nucleophile present. SN1 and E1 are both possible for this molecule. The first step in both reactions is carbocation formation. For SN1, the methanol would then attack the carbocation. After this step, the bromine in the solution would be able to deprotonate the methanol, leaving a neutral species. For the E1 mechanism, after the carbocation is formed, a neighboring carbon would need to be deprotonated to form a double bond. However, as this reaction is occurring in methanol, which is a neutral nucleophile as well as a protic solvent, the SN1 mechanism would be favored over the E1. As the mechanism goes through the formation of a carbocation intermediate, the methanol is able to attack the molecule from either side. This can form either of the products above, which is called a racemic mixture. This slide is a chart which shows the conditions that will cause a reaction to favor SN1, E1, SN2, or E2. This slide shows the complete mechanism with all curly arrows as you would need to draw for an exam. Thanks for watching the video. If you found it helpful, please leave us a like or a comment, and subscribe if you'd like to see future videos of mechanisms in motion.